On November 8, 1942, above the Gilbert Islands in the vast Pacific Theater, Lieutenant Robert Scott found himself in a terrifying predicament. Piloting his P-40 Warhawk, he executed a sharp left bank as a barrage of tracers from a Japanese Zero narrowly missed his aircraft's canopy. With his thumb poised over the gun trigger, he anticipated unleashing the formidable power of 6 Browning .50 caliber machine guns, then considered America's most lethal aerial armament. However, upon squeezing the trigger, an alarming silence met his efforts. All 6 guns simultaneously failed to discharge. The Zero pilot, observing Scott's sudden inability to return fire, swiftly maneuvered for a decisive kill. In a desperate attempt to survive, Scott pushed his P-40 to its absolute operational limits, plummeting into a steep dive and narrowly escaping into the protective embrace of cloud cover. Upon landing back at Henderson Field, his heart was still pounding furiously, and his aircraft bore the visible scars of numerous bullet holes. He immediately reported the critical malfunction to his commanding officer, stating unequivocally, "The guns jammed, all 6 within the first burst." This wasn't an isolated event. A disturbing pattern of catastrophic failure rates with the .50 caliber Browning M2 machine guns was emerging across the Pacific, from the intense battlegrounds of Guadalcanal to the dense jungles of New Guinea. The statistics were truly alarming. Throughout 1942, these M2 Brownings experienced a jam rate between 18% and 22% in aerial engagements. This meant that nearly 1 in 5 guns would fail at the most crucial moments of combat. For aircraft equipped with 6 or 8 of these weapons, the probability of at least one jamming during any given engagement soared to approximately 75%. We invite you to stay with us and watch the end of the video to uncover the full story. We would be incredibly grateful for your like and subscription. Please also share a comment below, letting us know where you are from and what you think about this critical video topic. The root of the problem was not inherent in the gun's fundamental design, a testament to John Browning's masterful engineering before his passing in 1926. Instead, the issue revolved around the precise synchronization of headspace and timing. The exact millisecond coordination required for the bolt to fully close before the firing pin struck the primer. When these critical parameters were incorrectly set, the weapon would either fail to fire entirely or, far more perilously, detonate rounds while the bolt was still partially open, leading to the destruction of the gun itself and posing a significant threat to the aircraft. Every M2 machine gun necessitated manual adjustment of both headspace and timing, following barrel changes or periods of intensive use. Field armorers were expected to employ specialized gauges and adhere to stringent procedures. However, under the brutal realities of combat, amidst tropical heat, battle damage, and the presence of worn components, these delicate adjustments transformed into a deadly gamble. Incorrectly calibrated timing could precipitate 3 distinct and catastrophic failure modes. Premature timing caused rounds to ignite before the bolt had fully closed, resulting in case ruptures that inevitably jammed the action. Conversely, if the firing pin struck after the bolt had begun to open, it created dangerous pressure spikes within the chamber. And finally, excessive headspace allowed cartridge cases to separate during firing, effectively jamming the chamber. The grim consequence was American pilots confronting enemy fighters with weapons that unpredictably ceased to function, and bomber crews over Germany witnessing their vital defensive .50 caliber guns fall silent as aggressive Luftwaffe fighters closed in for the attack. What remained unknown at the time, what no one could foresee as Lieutenant Scott walked away from yet another brushes with death, was that the definitive solution to this escalating crisis had actually been devised a decade earlier by an unsung Springfield Armory gunsmith who employed an unconventional approach to testing. His name was Samuel Green, and his seemingly suicidal-proof testing methodology was on the cusp of salvaging the entire .50 caliber program from the brink of abandonment. The genesis of the Browning .50 caliber M2 machine gun dates back to 1918, nearing the conclusion of World War I. John Moses Browning, widely acclaimed as America's preeminent firearms designer, ingeniously scaled up his highly successful .30 caliber M1917 design to accommodate the immense .50 BMG Browning machine gun cartridge. The cartridge itself was a behemoth. Measuring 5.5 inches in length, it propelled a 700-grain bullet at an astonishing velocity of 2,900 feet per second. This formidable round possessed the capability to penetrate aircraft armor at distances up to 1,500 yards and could effectively disable vehicles, establishing its reputation as the quintessential anti-aircraft and anti-material weapon. However, when the inaugural production model, the M1921, entered service in 1921, it proved to be an intricate nightmare. The M1921 was produced in 7 distinct configurations: water-cooled, air-cooled, aircraft-mounted, tank-mounted, anti-aircraft, flexible, and fixed. Each variant demanded unique parts, different maintenance protocols, and specific timing adjustments. Most problematic of all, both the timing and headspace required manual adjustment by armorers every time the barrel was replaced, a frequent necessity in combat scenarios. The involved procedure entailed inserting a go gauge to establish the minimum headspace, followed by a no-go gauge to set the maximum headspace, meticulously adjusting the barrel lock nut in precise increments, then setting the timing with a separate gauge while manually cycling the action, and finally, test firing and readjusting if any malfunctions were observed. In a well-equipped workshop with appropriate tools and sufficient time, an expert armorer could accomplish this entire procedure in approximately 20 minutes. Yet, under the harsh realities of combat, whether on a pitching aircraft carrier, in a forward airfield subjected to artillery fire, or within the rain-soaked jungles of the Pacific, this complex process became an incessant source of critical problems. The repercussions were undeniably deadly. A comprehensive study conducted by the Army Ordnance Department in 1925 scrutinized 500 M1921 machine guns already in service. The findings were unequivocally damning. A staggering 47% of these weapons exhibited incorrect headspace settings, and an even higher 61% suffered from incorrect timing. The average time between failures was a mere 840 rounds, translating to less than 2 minutes of sustained fire. Furthermore, 23% of barrel changes resulted in weapons that were completely inoperable. The consensus among experts was clear. The M1921 was simply too complex for effective field deployment. Major General C.C. Williams, the Chief of Army Ordnance, articulated this concern in 1928, stating, "The current .50 caliber machine gun represents the limits of what can be achieved with manual timing adjustment. Unless a fundamental redesign eliminates the need for field timing, this weapon will remain unreliable in combat conditions." The Army seriously contemplated abandoning the .50 caliber program entirely. Some officers advocated for the adoption of 20mm cannons instead, citing their fewer number of guns, simpler maintenance requirements, and proven European technology. However, a significant drawback existed with cannons, their rate of fire. The 50 caliber M11921 could unleash 450-600 rounds per minute, whereas most 20mm cannons fired only 60 to 120 rounds per minute. In the dynamic environment of aerial combat, where targets appeared and vanished in mere seconds, the sheer volume of fire was as crucial as the individual hitting power of each round. The Army found itself facing an untenable choice: persevere with an inherently unreliable weapon, or transition to a system with demonstrably inadequate firepower. This dilemma was further compounded by John Browning's death in 1926, which left the 50 caliber program bereft of its visionary genius. Development subsequently stalled. Various engineers put forth proposed modifications, including stronger springs, revised bolt designs, and different barrel lock mechanisms, but none succeeded in resolving the fundamental issue: the gun's dependence on expert adjustment that was virtually impossible to achieve consistently under combat conditions. By 1930, the United States military had channeled a substantial sum, precisely $2.3 million, into the development of its .50 caliber weapon systems, an investment that would equate to a staggering $42 million in today's economy. Yet, despite this considerable expenditure, there was remarkably little tangible progress to report. While the M19 AIM-21 model continued to see limited deployment, a palpable sense of disillusionment began to permeate the ranks of military strategists and planners. At the venerable Springfield Armory in Massachusetts, the nation's foremost institution for small arms innovation, a dedicated but dwindling team persevered in their pursuit of improvements. However, their financial resources were severely curtailed, and the program's strategic importance had been significantly downgraded. Consequently, many of the Armory's most brilliant and experienced engineers were redeployed to other, more prioritized endeavors. It was against this backdrop of declining fortunes and diminishing hope that Samuel Green assumed leadership of the beleaguered project. Samuel Green, however, was not the typical figure one might expect to head a firearms development program. His professional acumen lay not in the intricate art of weapon design, but rather in the meticulous disciplines of mechanical engineering, specializing particularly in manufacturing processes and stringent quality control. His expertise was forged in the demanding world of precision machining, a field distinct from the traditional realm of armament conception. The Army's decision to assign him to the 50 caliber initiative stemmed primarily from a lack of willing candidates. The program was widely perceived as a professional dead end, a graveyard for promising careers. What the military leadership failed to grasp at the time was the profound irony. Green's profound understanding of manufacturing was precisely the expertise the M2 machine gun desperately required. The core issue, as he would quickly discern, was not a fundamental flaw in the weapon's design itself, but rather the formidable challenge of properly maintaining that design under the unforgiving conditions of active combat. Green's groundbreaking approach began with a simple yet revolutionary inquiry, a question no one else had dared to pose. What if we could entirely eliminate the necessity for field adjustments? Samuel Green hardly conformed to the popular image of a weapons design prodigy. Born in 1891 in the industrial hub of Worcester, Massachusetts, Green's formative years were deeply rooted in the heartland of American manufacturing. His father operated a modest machine shop, primarily engaged in the production of textile machinery. From the tender age of 14, Green was immersed in the practical realities of the shop floor. diligently acquiring essential skills such as interpreting complex blueprints, operating sophisticated lathes, and meticulously maintaining precision tolerances. He later pursued higher education at Worcester Polytechnic Institute, earning a partial scholarship to study mechanical engineering. His undergraduate thesis, a detailed exploration into the reduction of manufacturing variation in components destined for mass production, was reportedly so dry that his academic advisor found it challenging to remain awake during its defense. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Please write a comment about where you are from and what you think about the video topic. Despite its seemingly unexciting nature, Green's central insight was nothing short of revolutionary for its era. He posited that exceptionally tight manufacturing tolerances could completely obviate the need for manual adjustments after assembly. His theory suggested that if individual components were fabricated with sufficient precision, they would seamlessly integrate and function flawlessly upon assembly, rendering the intervention of skilled technicians to fiddle with them utterly unnecessary. This was 1913, a time when the groundbreaking concept of the assembly line was barely a decade old, still in its nascent stages. The vast majority of manufacturers still operated under the assumption that workers would be required to painstakingly hand-fit components. Consequently, Green's pioneering ideas were largely dismissed as impractical, deemed prohibitively expensive, and considered too challenging to achieve with the existing industrial machinery of the day. Following his graduation, Green embarked on a career path that saw him working for a diverse array of manufacturing companies. Through diligent effort and a knack for problem-solving, he gradually cultivated a formidable reputation as the individual capable of resolving seemingly insurmountable tolerance challenges. When the Great War erupted, he was swiftly recruited to the esteemed Springfield Armory, tasked with the crucial mission of significantly increasing rifle production. He chose to remain at the armory after the cessation of hostilities, dedicating his expertise to refining manufacturing processes for iconic weaponry such as the M1903 Springfield rifle, the M1911 pistol, and various machine gun models. By 1930, Green had reached the age of 40, a senior engineer with an unblemished professional record. Yet remarkably, he had received virtually no public recognition for his profound contributions. His tireless work was instrumental in enabling the mass production of designs conceived by others, making their innovations widely available. But the manufacturing guy himself remained largely unsung and unremembered. When the .50 caliber program teetered on the precipice of outright cancellation, it was Samuel Green who, against all odds, courageously volunteered to assume its leadership. His supervisor, understandably, harbored deep skepticism regarding this decision. "Sam," his superior cautioned, "this program has proven to be the undoing of some of our most brilliant designers. Even the legendary Browning himself could not resolve the persistent timing problem before his passing." Green, however, met this doubt with a calm yet firm conviction. "That's because they're approaching it as a design problem," he countered succinctly. "In reality, it is fundamentally a manufacturing problem." Over the course of 3 intensive months, Green immersed himself in a meticulous and exhaustive investigation. He painstakingly scrutinized every single failure report, every field complaint lodged by operators, and every documented instance of malfunction. He engaged in extensive interviews with armorers, seeking their first-hand insights into the weapon's operational quirks. He observed them assiduously as they attempted to precisely set headspace and timing under simulated combat conditions, gaining a visceral understanding of their challenges. Furthermore, he personally fired thousands of rounds through M1921 models, deliberately introducing worn parts, damaged components, and improper adjustments to systematically identify the root causes of failure. His ultimate conclusion was stark and undeniably damning. The M1921's timing adjustment mechanism was excessively sensitive, bordering on the impractical. He discovered that a mere quarter turn of the timing nut, representing a minuscule movement of less than 1 millimeter, constituted the critical threshold separating flawlessly reliable operation from catastrophic mechanical failure. It became undeniably clear that no armorer, however skilled or experienced, could consistently achieve such exacting precision under the chaotic and stressful conditions of active combat. The logical solution, therefore, became strikingly obvious to Green. The weapon needed to be fundamentally redesigned so that its timing could be meticulously set at the factory, thereby eliminating any subsequent requirement for field adjustment. However, implementing such a radical solution presented a monumental challenge. A fixed timing mechanism demanded that the machine gun perform flawlessly with every single barrel under every conceivable environmental condition, and despite every slight variation inherent in mass manufacturing. The required tolerances were tighter, more exacting than anything Springfield Armory had ever successfully achieved in its history. Green's supervisor articulated this formidable hurdle with blunt honesty. "Sam, what you are proposing necessitates a level of manufacturing precision that currently lies beyond our existing capabilities. We simply cannot maintain such incredibly tight tolerances across the production of thousands of individual guns." "Then we will improve our manufacturing," Green stated with unwavering resolve, "because there is no other viable solution." What unfolded next is precisely where Samuel Green's unconventional methodologies and his profound willingness to stake everything on his convictions irrevocably altered the trajectory of weapons history forever. On a pivotal day, March 15, 1932, at the Springfield Armory, Samuel Green stood within the confines of the test bunker alongside the very first prototype of what would ultimately be known to the world as the M2 Browning machine gun. The comprehensive redesign process had consumed 18 arduous months, during which every critical dimension of the weapon had been painstakingly refined and optimized. The barrel lock mechanism in particular had undergone a complete overhaul, meticulously engineered to entirely eliminate the problematic need for timing adjustment in the field. Furthermore, the headspace was now meticulously set at the factory using precision gauges capable of accuracy down to an astonishing 0.01 inches, a standard of precision that was a remarkable tenfold improvement over all preceding benchmarks. Yet Green understood implicitly that precision manufacturing, while indispensable, was not in itself sufficient. He felt an urgent imperative to conclusively demonstrate that the redesigned gun would function with absolute reliability, even when subjected to the most brutally unforgiving conditions imaginable. His chosen solution was both elegantly simple and, to many, utterly insane. Green had conceived and developed what he termed a proof round, a specially prepared .50 BMG cartridge, loaded with an astounding 30% more propellant powder than standard military ammunition. The resultant chamber pressure generated by this round soared to over 70,000 psi, a force dramatically exceeding the weapon's intended design limits. Should any single component possess even the slightest manufacturing flaw, or if any tolerance deviation, no matter how minute, even a fraction of a millimeter, were present, the machine gun would inevitably suffer a catastrophic failure. At the staggering pressure of 70,000 psi, such a failure would signify the explosive disintegration of the receiver itself. Shrapnel, propelled at supersonic velocities, would erupt in all directions, posing an immediate and lethal threat to anyone within a radius of 20 feet. The test bunker, while robustly constructed to safeguard observers from the hazards of routine weapons testing, was simply not engineered to contain the violent and devastating explosion of a .50 caliber machine gun operating under such extreme and unprecedented stresses. The initial reaction from Dr. Green's assistant, a relatively junior ordnance officer named James Patterson, was one of profound shock and alarm upon witnessing the specially prepared proof rounds. He immediately expressed his grave concerns, exclaiming that the proposed testing methodology was insane. Patterson emphasized the extreme danger, stating unequivocally that an explosion of the weapon under such conditions would conclusively indicate a critical failure in the manufacturing tolerances, proving them to be inadequately precise for the demands of the design. He further warned Dr. Green of the potential for a fatal outcome, highlighting the personal risk involved in such a perilous endeavor. Dr. Green, however, remained resolute, calmly asserting that should he perish, another individual would simply have to step forward and complete the vital project. Compelled by his serious misgivings, Patterson promptly escalated Dr. Green's audacious plan to the attention of Colonel Howard, the commanding officer of the Armory. Within moments of receiving this alarming report, Colonel Howard swiftly arrived at the test bunker, confronting Dr. Green directly. The colonel immediately addressed the core issue, stating, "Dr. Green, I understand you're planning to test your prototype with overloaded ammunition." Dr. Green confirmed his intentions, defending his approach by explaining that proof testing constituted a standard operational procedure. However, Colonel Howard vehemently disagreed with the extreme nature of the proposed test, specifically the 30% overload, which he deemed suicidal, stressing that even the robust bunker would offer insufficient protection in the event of a catastrophic failure. Dr. Green countered by articulating his unwavering conviction if the weapon could not withstand such rigorous proof loads, it was inherently unfit for the battlefield. He underscored the profound responsibility they bore to the soldiers whose lives would ultimately depend on the weapon's flawless performance, insisting on the absolute necessity of verifying its reliability under the most extreme conditions. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. Colonel Howard proposed a more conventional and staged approach to the proof testing, suggesting an incremental increase in overload, beginning with a 10% increment and then escalating to 15%. Dr. Green, however, firmly rejected this cautious methodology. He maintained that such graduated testing would prove insufficient in uncovering fundamental manufacturing defects, asserting that the weapon absolutely needed to demonstrate its resilience under the most severe, worst-case conditions imaginable. Colonel Howard, exasperated, pointed out that this extreme testing directly contravened every safety protocol established for such procedures. Dr. Green, while maintaining a respectful demeanor, passionately argued that the existing M1-1921 model tragically contributed to American casualties due to its inherent unreliability in combat situations. He declared his unyielding resolve he would not grant approval for the new design's production until he had personally and unequivocally verified its capacity to withstand conditions significantly more arduous than any encountered on the battlefield. A prolonged and intense silence filled the bunker. As Colonel, Howard fixed his gaze upon Dr. Green, a palpable tension hanging in the air. Finally, the Colonel broke the quiet, expressing his personal apprehension. "If you die doing this, I'm going to look like an idiot for allowing it." Dr. Green's response was delivered with quiet confidence and a hint of wry determination. "Then I'd better not die, sir." After this poignant exchange, Colonel Howard, recognizing the profound conviction and the critical importance of Green's mission, reluctantly affixed his signature to the authorization document. With the necessary approval secured, Dr. Green proceeded to meticulously load the 10 specialized proof rounds. Each of these rounds possessed an immense destructive potential, individually capable of utterly demolishing the machine gun. As he chambered the very first round, his hands remained remarkably steady, betraying no sign of hesitation or fear. He had painstakingly calculated every variable, every stress point, and the complex mathematical models indicated that the weapon would indeed endure. Now the ultimate test of those calculations lay before him. With a deep breath, Dr. Green deliberately pulled the trigger. The pivotal moment arrived on March 15, 1932, at precisely 2:47 p.m. at the Springfield Armory Test Range. The first proof round detonated with an absolutely deafening report, a sharp, metallic crack that reverberated powerfully across the entire testing facility. The resulting recoil was extraordinarily violent, causing the robust test mount to visibly shake and vibrate. Yet, against the initial fears, the machine gun miraculously did not explode. Its critical receiver section held firm, and the barrel remained entirely intact, showing no signs of catastrophic failure. Without hesitation, Green swiftly chambered the second round and fired, observing with satisfaction as the weapon cycled flawlessly. He continued this nerve-wracking process, firing the third, fourth, and fifth rounds in rapid succession. By the time the 10th and final proof round was discharged, James Patterson, initially cowering behind the protective bunker wall, had emerged from his sheltered position. He now stood directly alongside Dr. Green, completely captivated and utterly mesmerized by the weapon's astonishing performance under such extreme duress. A hushed gasp escaped Patterson's lips as he uttered its holding, his voice barely above a whisper, reflecting his profound awe and disbelief. Dr. Green meticulously commenced his post-firing examination of the formidable weapon. The barrel radiated such intense heat that the very air around it visibly shimmered and distorted. With a practiced and discerning touch, he carefully ran his fingers across the receiver, searching intently for any indication of compromise. The telltale hairline cracks, subtle bulges, or any other discernible signs of immense stress. "Nothing," he declared, a quiet triumph in his tone, confirming the absence of any visible damage. He then proceeded to expertly disassemble the bolt mechanism, scrutinizing each component. To his immense satisfaction, there was no evidence of deformation, and the crucial locking lugs, which bore the brunt of the firing forces, exhibited absolutely no damage whatsoever. "It worked," Green stated softly, a profound sense of vindication resonating in his voice. The stringent manufacturing tolerances against all odds and dire predictions had indeed held true. During the ensuing 3-week period, Dr. Green relentlessly put 6 prototype M2 machine guns through an escalating series of truly brutal and exhaustive trials. This rigorous regimen included the continuous firing of an astonishing 50,000 rounds, with barrel replacements mandated every 5,000 rounds to assess durability under sustained use. Furthermore, proof loads, designed to test the weapon's structural integrity to its limits, were administered every 500 rounds. The prototypes were subjected to extreme environmental assaults involving immersion in sand, thick mud, and corrosive salt water, immediately followed by live firing to test resilience. They were even frozen solid and subsequently fired without any cleaning or maintenance, pushing the boundaries of operational capability in harsh climates. To further challenge the design, tests incorporated deliberately worn barrels, pre-damaged parts, and intentionally misaligned components to simulate real-world battlefield degradation and improper assembly. The cumulative outcomes of this unprecedented testing methodology were nothing short of extraordinary, far surpassing all expectations. The stark contrast in performance data between the previous model and Green's innovative redesign was undeniably compelling. The M1921 Browning, the antecedent machine gun, exhibited an average operational life of merely 840 rounds before encountering its initial malfunction. It experienced an alarming rate of 12.3 malfunctions for every 1,000 rounds fired, necessitating armorer adjustments with every single barrel change, representing a 100% requirement. Consequently, its overall field reliability rating stood at a rather disappointing 68%. In stark opposition, the M2 Browning, representing Dr. Green's radical and meticulously engineered redesign, demonstrated an astonishing average of 423 Thi-200 rounds before experiencing its first malfunction. Its malfunction rate plummeted dramatically to an exceptional 2.1 per 1,000 rounds, and remarkably, it required absolutely no armorer adjustments whatsoever after a barrel change, boasting a 0% requirement. These unparalleled improvements culminated in an outstanding field reliability rating of 94%, setting a new benchmark for machine gun performance. Following the conclusive and overwhelmingly positive results of his extensive testing, Dr. A. Green promptly compiled and submitted his comprehensive report to Army Ordnance. Accompanying this detailed account of the M2's superior performance was a clear and unequivocal recommendation. Approve the M2 for immediate production, underscoring his conviction that the weapon was not only ready but urgently needed for deployment. On April 8, 1932, a pivotal meeting of the Army Ordnance Board convened in Washington, D.C., bringing together a distinguished assembly of 12 senior military officers and highly regarded civilian weapons experts. Their collective purpose was to meticulously review Dr. Green's groundbreaking M2 proposal. Despite having perused his detailed test data, a pervasive skepticism lingered among the attendees, given the truly extraordinary nature of the reported results. Colonel Frederick Rice, serving as the Chief Weapons Procurement Officer, took the lead in the subsequent interrogation. He directly addressed Dr. Green, acknowledging that his test results were indeed impressive, but immediately qualified this by stating they were also unprecedented, emphasizing that no machine gun in recorded history had ever attained such an exceptional 94% reliability rating under rigorous field conditions. Dr. Green, undeterred by the skepticism, responded forthrightly, asserting that the unparalleled reliability stemmed from the fact that no machine gun has ever been manufactured to tolerances this tight. Colonel Rice seized upon this very point, stating, "That's precisely the problem." He argued that Green's innovative design demanded a level of manufacturing precision that simply could not be sustained or replicated in the context of mass production. He contended that the exceptional performance achieved with merely 6 meticulously hand-built prototypes would inevitably prove unattainable when scaled up to an order of 50,000 production guns. Another expert then interjected, adding to the fiscal concerns, "Sir, I've developed detailed manufacturing specifications which most contractors won't be able to meet. And even if they could, the cost would be prohibitive. Your M2 will be twice as expensive to produce as the current M1921. This introduced a significant financial hurdle, further complicating the proposed adoption. Major General Williams then interjected, shifting the focus to another contentious aspect, Dr. Green's unorthodox proof testing methodology. He highlighted the alarming practice of loading ammunition 30% over pressure, unequivocally stating that such a procedure was far from standard. The general revealed that some members of his staff held the firm belief that Green's testing had been unnecessarily dangerous and violated safety protocols. Dr. Green, ever steadfast, maintained that the testing proved the design's robustness, asserting the validity of his extreme approach. Major General Williams retorted with a sharp counter-argument, suggesting that the tests might instead have merely demonstrated Green's recklessness. He then launched a more personal attack on Green's professional credibility, reminding him, "Dr. Green, you're a manufacturing engineer, not a weapons designer." He further underscored that this redesign constituted a radical departure from Browning's original concept, concluding with a pointed and challenging question, "Are you suggesting you know better than John Browning?" A direct challenge to Green's authority and innovation. At this critical juncture, the room erupted into a cacophony of heated arguments and impassioned debates, the carefully maintained decorum dissolving under the weight of conflicting opinions. Voices rose as various experts and officers passionately articulated their perspectives. One individual vehemently asserted, "The test data is undeniable," emphasizing the irrefutable evidence of the M2's superior performance. Another countered sharply, declaring that test data means nothing if we can't mass-produce the weapon, highlighting the practical challenges of scalability. A different faction proposed a fundamental shift in strategy, suggesting we should be looking at 20mm cannons instead, advocating for an entirely different class of weaponry. Yet another voice reminded the assembly of the significant financial commitment already made, stating emphatically, "The Army has invested millions in .50 caliber development." The meeting devolved into a chaotic exchange, reflecting the deep divisions and high stakes involved in the decision. Throughout this tumultuous eruption of dissent, Dr. Green maintained a dignified silence, a quiet observer as his meticulously crafted work and innovative proposals were systematically dissected and seemingly dismantled by the formidable forces of institutional bureaucracy. Just as the debate reached its peak, an unexpected and dramatic shift occurred. General Douglas MacArthur, the formidable Army Chief of Staff, the highest-ranking officer in the entire U.S. Army, strode purposefully into the room. His arrival was entirely unscheduled, an unforeseen intervention. The sheer gravitas of his presence was instantaneous and absolute, immediately silencing every voice and bringing the contentious proceedings to an abrupt and profound halt. Addressing the now hushed assembly, General MacArthur began with a commanding tone, simply stating, "Gentlemen." He then proceeded to reveal the weight of his personal involvement, explaining that he had not only thoroughly reviewed Dr. Green's test data, but had also meticulously examined casualty reports from field exercises where M1921 machine guns failed during simulated combat. With an air of absolute authority, he delivered his unequivocal verdict. The current gun is killing Americans through unreliability. He concluded with a powerful endorsement of Green's innovation, asserting with finality, "Dr. Green's design solves that problem, thereby cutting through all previous arguments and decisively shifting the direction of the meeting. The prevailing issue of unreliability, a critical flaw that often jeopardized the lives of American servicemen, was decisively addressed by Dr. Green, innovative design." Despite initial reservations, Colonel Rice staunchly defended the new weapon. He firmly asserted that any manufacturing complexities would inevitably be surmounted, unequivocally authorizing immediate production trials. His resolve was absolute. If existing contractors proved incapable of adhering to Dr. Green's exacting tolerances, new, more proficient manufacturers would be secured. With this unwavering declaration, the M2 machine gun received its official approval. A profound silence enveloped the room as General MacArthur turned to Dr. Green, entrusting him with the personal oversight of the production implementation and demanding the delivery of the inaugural production M2s within a rigorous 6-month time frame. Dr. Green's concise affirmation, "Yes, sir," sealed the momentous decision. This pivotal instant marked a profound paradigm shift, forever altering the landscape of aerial warfare. Yet, the ultimate validation of the M2's revolutionary potential still lay ahead, awaiting its true test amidst the unforgiving skies of Europe and the Pacific. On December 15, 1933, a significant milestone was reached as the very first production M2 Browning machine guns meticulously rolled off the assembly line at the historic Springfield Armory. Dr. Green, demonstrating his unwavering commitment to precision, personally scrutinized the initial 100 units, meticulously verifying every critical dimension to ensure that the stringent manufacturing tolerances were consistently upheld. By the middle of 1934, the United States military commenced the phased replacement of its aging M1921s with the superior M2s. However, this transition was inherently a protracted undertaking, given the thousands of M1921s still in active service and the widespread reluctance among many seasoned commanders to embrace an armament that, despite its promise, remained largely untested in widespread operational scenarios. The irrefutable evidence of the M2's exceptional capabilities subsequently emerged from an entirely unforeseen theater. In July 1937, with the outbreak of the Second Sino-Japanese War, American volunteer pilots, the pioneering precursors to the legendary Flying Tigers, who were actively engaged with the Chinese Air Force, began to receive some of the earliest aircraft equipped with the M2. Their subsequent dispatches back to the United States were unequivocally unanimous: the M2 is a revelation. Captain Claire Chennault, a prominent figure in this early conflict, articulated the transformative impact, stating that the M2 Browning has fundamentally changed aerial combat. He highlighted that pilots could now engage enemy aircraft with an unprecedented level of confidence, assured that their weaponry would not falter. Remarkably, across 63 confirmed aerial victories, only 2 gun malfunctions were recorded, both attributed not to inherent mechanical failure, but to direct combat damage, a testament to the weapon's extraordinary robustness. Please stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. Nevertheless, the definitive crucible for the M2 arrived with the advent of World War II. A vivid illustration of its prowess occurred on February 20, 1942, in the skies above Java, Netherlands East Indies. Lieutenant Garrett "Shorty" Whitaker, at the controls of a P-40 Warhawk armed with 6 M2 Brownings, 3 strategically mounted in each wing, found himself confronting Japanese Zeros that outnumbered American aircraft by a staggering 3-to-1 margin. Observing a Zero aggressively diving on his wingman, Whitaker executed a sharp bank, swiftly aligned his shot, and firmly squeezed the trigger. All 6 M2s discharged in flawless synchronization, unleashing a concentrated torrent of fire that caused the enemy Zero to instantly disintegrate. As another Zero launched an attack from above, Whitaker masterfully rolled his aircraft inverted, pulled through the maneuver, and skillfully positioned himself on the attacker's tail. Another precise burst from his M2s tore the Zero's wing clean off. Whitaker persevered in the dogfight for an arduous 18 minutes. An eternity in the brutal realm of aerial combat, expending 2,400 rounds without a single malfunction, ultimately securing 3 confirmed kills. He returned to base with his ammunition bays depleted and his aircraft significantly damaged, yet every single gun remained fully operational. His concise report to intelligence contained a powerful, unambiguous declaration: "These .50 calibers are the only reason I'm alive." Following these initial combat reports, comprehensive data began to inundate intelligence centers from every operational theater, painting a clear picture of the M2 Browning, his exceptional performance between 1942 and 1945. The statistics were compelling. Over 2 billion rounds were fired in combat, with an astonishingly low average malfunction rate of merely 1.8 per 10,000 rounds. Furthermore, only 4. 2% of guns required replacement annually due to wear, culminating in an impressive field reliability rating of 96.3%. This remarkable consistency stood in stark contrast to the M1921 Browning's combat performance from 1927 to 1941, which recorded an average of 11.4 malfunctions per 10,000 rounds, a substantial 23% annual replacement rate due to wear, and a significantly lower field reliability rating of 71%. The M2's unparalleled dependability thus translated directly into a quantifiable preservation of human lives. Another harrowing yet illustrative account unfolded on June 13, 1944, over the embattled skies of Normandy, France. Captain Robert Johnson, piloting a P-47 Thunderbolt, found himself in a desperate engagement against a formidable force of 25 German fighters. His aircraft endured repeated hits. Cannon shells mercilessly tore through the fuselage, shredded the wings, and utterly destroyed the canopy. Johnson himself sustained injuries, and his Thunderbolt was barely controllable, yet his 8 M2 Brownings continued to fire relentlessly. In the ensuing running battle back towards England, he managed to shoot down 3 German fighters. Upon his eventual perilous crash landing at his base, armament officers meticulously counted 225 holes riddling his aircraft. The M2s had expended 4,800 rounds, suffering only a single malfunction, a damaged ammunition feed, which was directly attributable to a 20mm cannon hit. Captain Johnson's survival was unequivocally credited to the unwavering performance of his armament. Such narratives of steadfast reliability multiplied across all fronts. In the vast expanse of the Pacific Theater, Marine Corps Wildcats and Corsairs, each armed with the formidable M2s, consistently demonstrated overwhelming air superiority against Japanese aircraft. The kill ratio decisively shifted in favor of American pilots, a triumph attributed partly to their superior tactics and rigorous training, but undeniably and significantly to the M2's unmatched and consistent reliability. From the German perspective, post-war interrogations of captured Luftwaffe pilots offered invaluable insights into the effectiveness of American weaponry. Major Hans Eckardbob, a distinguished German ace credited with 60 aerial victories, articulated his assessment to Allied intelligence. He stated that the American .50 caliber was devastating, clarifying that its impact stemmed not from individual power, as it was not inherently more potent than their 20mm cannon, but from the sheer volume and unwavering functionality of multiple weapons. He explained that American fighters typically carried 6 or 8 guns, and critically, all of them worked every time. Engaging an American fighter meant confronting a coordinated fusillade from numerous weapons with no lucky jam to offer a fleeting advantage. In contrast, while their MG-151 cannons were powerful, they frequently malfunctioned, a stark difference to the consistent performance of the American guns. Oberst Johannes Steinhoff, another highly decorated German ace, further corroborated this sentiment, adding that we feared the P-51 and P-47 not just for their performance but for their firepower. He unequivocally declared the .50 caliber Browning to be the most reliable aerial weapon of the entire war. Steinhoff emphasized the psychological impact. When American pilots initiated fire, German pilots knew with grim certainty that every gun would continue to discharge until its ammunition was exhausted. Against such unyielding reliability, he conceded, even superior tactics could not always guarantee survival. The compelling numerical data from 1943 to 1945 provides a definitive combat effectiveness comparison. American fighters equipped with M2 Brownings required an average of 1 to 800 rounds per air victory, experienced a minuscule gun malfunction rate, causing mission aborts of 0.7%, and boasted an impressive pilot confidence rating in their weapons of 94%. Conversely, German fighters utilizing MG-151-20 cannons, while requiring fewer rounds per air victory, 8 and 70 average, suffered a significantly higher gun malfunction rate, leading to mission aborts at 8.2% and a markedly lower pilot confidence rating of 73%. These figures underscore a crucial point. While German guns possessed greater individual power per shot, the M2's unparalleled reliability ensured that American pilots could consistently and effectively bring their formidable firepower to bear when it mattered most. The M2's enduring legacy of dependability was further cemented in August 1945 during B-29 operations over Japan. Each B-29 superfortress, acting as a defensive fortress, was equipped with up to 12 M2 Brownings. During these high-altitude bombing missions, these machine guns were required to function flawlessly in extreme conditions, enduring temperatures as low as 40 degrees Celsius and operating at altitudes where the air was too thin for human respiration, without oxygen masks. Yet, under these immensely challenging circumstances, the M2s performed with unwavering perfection. The M2 heavy machine guns, renowned for their unwavering performance, operated with remarkable consistency. Gunnery Sergeant Michael McGuire, who served as a tail gunner aboard the B-29 City of Los Angeles, discharged an impressive 18,000 rounds across 35 combat sorties. Throughout this extensive engagement, his weaponry experienced only 2 minor malfunctions, both stemming from frozen condensation that readily dissipated after a brief burst of fire. I placed my absolute trust in those .50 caliber machines with my very existence, McGuire later recounted, reflecting on his wartime experiences. When Japanese fighter aircraft converged upon us, I possessed an unwavering certainty that my armaments would respond. That profound assurance, the conviction that your instrument of defense will not betray you, was the bedrock that sustained my composure through 35 arduous missions over the skies of Japan. The quantitative impact of this enhanced reliability is truly profound. Expert military analysts have calculated that the improved dependability of the M2 machine gun was instrumental in preserving approximately 2,800 aircraft that would otherwise have been lost due to failures in defensive armaments. Furthermore, this reliability is credited with safeguarding the lives of 18,600 aircrew members aboard bombers that successfully repelled enemy attacks, and additional 4,200 fighter pilots who survived aerial confrontations because their guns functioned as intended. The groundbreaking manufacturing innovations introduced by Samuel Green, coupled with his extraordinary willingness to validate these advancements through perilous, self-endangering trials, collectively prevented the loss of over 25,000 American lives. Indeed, one individual's singular dedication to achieving unparalleled precision in manufacturing ultimately preserved the lives of tens of thousands. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. On May 8, 1945, a day celebrated as VE Day, Samuel Green found himself at the Springfield Armory, observing newsreel footage of American forces exultantly commemorating victory in Europe. On the screen, soldiers discharged M2 Brownings in a display of jubilation. Those very weapons, products of his meticulous engineering, had played a crucial role in securing the Allied triumph. Yet beyond the confines of Springfield Armory, his name remained largely unknown. John Browning was universally lauded as the brilliant inventor behind the M2, while General MacArthur received credit for authorizing its mass production. Distinguished aces like Bong and McGuire were rightfully celebrated for their combat achievements. Samuel Green, the dedicated manufacturing engineer whose efforts transformed the M2 into a truly operational and reliable weapon, faded into obscurity. He appeared to harbor no resentment regarding this lack of public recognition. When a reporter from the Springfield local newspaper sought to interview him about his contributions to the M2's development, Green humbly declined, stating, "John Browning conceived the weapon. I merely rendered it suitable for production. That hardly constitutes a compelling narrative. The sheer numerical scale of the M2's production, by the conclusion of the war, is nothing short of astounding." More than 2,000 M2 units were manufactured, and an estimated 2.3 billion rounds were expended in combat operations. Its service longevity is equally remarkable, remaining actively deployed over 80 years since its inception. The M2 has been adopted by military forces in more than 100 nations, solidifying its status as the longest-serving military weapon in the annals of American history. The fundamental design, meticulously refined by Green in 1933, continues to operate effectively on front lines across the globe today. Contemporary M2A1 variants incorporate advanced materials and sophisticated manufacturing methodologies, yet the foundational design, crucially including Green's precisely engineered timing mechanism, endures without alteration. This represents a significant modern legacy. Presently, every branch of the United States military employs M2 Brownings, time 2s. These formidable weapons are integrated onto a diverse array of platforms, including Humvees, naval vessels, various aircraft, and fixed ground emplacements. Elite Special Operations Forces routinely carry them, Navy SEALs affix them to their patrol boats, and Marine Corps units depend heavily upon their firepower. In recent conflicts, such as those in Afghanistan and Iraq, M2s discharged millions of rounds, exhibiting the identical legendary reliability that Green painstakingly engineered 9 decades prior. The weapon's extraordinary durability and sustained performance unequivocally validate Green's core principle. Stringent manufacturing tolerances eliminate the necessity for constant field adjustments. While contemporary manufacturing techniques can achieve tolerances of 0.001 inches, far surpassing Green's capabilities, the underlying principle he championed remains absolutely pertinent. Samuel Green, the archetypal unassuming hero, concluded his career at Springfield Armory in 1953 at the age of 62. His retirement was marked by the receipt of the Army's Meritorious Civilian Service Award, a modest commendation comprising a certificate and a handshake, devoid of any public ceremony or press coverage. He passed away in 1968 at 77 years old. His obituary in the Springfield newspaper simply noted his profession as an engineer at Springfield Armory, making no mention of his pivotal role in the M2's development. However, in 1973, a contingent of World War II veterans, having discovered Green's indispensable contributions to the M2, sought out his widow, Evelyn. They presented her with a commemorative plaque bearing a heartfelt inscription. To Dr. Samuel Green, whose precision saved our lives. Because of your work, our guns never failed us. Because of you, we came home. The crews of the 8th Air Force will never forget. Evelyn Green was visibly moved to tears upon reading the tribute. Sam would have simply stated he was performing his duties, she reflected, but I believe he would have been immensely proud. The overarching lesson gleaned from this narrative is clear. Sometimes the most impactful innovations are not dramatic overhauls or revolutionary concepts. Rather, they manifest as subtle yet critical advancements in manufacturing precision. Frequently, the true hero is not the celebrated inventor, but the meticulous engineer who renders an invention genuinely functional. Samuel Green unequivocally demonstrated that exceptional execution holds as much significance as brilliant design. His readiness to subject his work to the most rigorous and destructive testing, literally jeopardizing his own life to validate his manufacturing exactitude, ultimately preserved 25,000 American lives. Therefore, the next time the iconic Browning M2, the weapon credited with helping to win the war, is mentioned, it is imperative to remember Samuel Green, the manufacturing gunsmith, whose unwavering dedication ensured its flawless operation.